Good morning. We will wait a minute. Get people in. Morning. Good morning. We will start soon. Hear me. Our two speakers is there. In. We wait a second. Okay. So here's some people. Okay, so we will start in order to give time. So good morning, everyone. My name is Arthur Guichet, and welcome to this webinar from the European Water Association and IDEXX on water reuse and microbiological requirements. I will be your moderator for today's. And before we start, first of all, so as I just said, this is webinar sponsored by IDEXX and co-organized with the European Water Association. So first of all, thank you for this support that's allowing us to make this event free of charge for the participants. And as mentioned, we'll talk then about water reuse and microbiological requirements. A few words about the European Water Association. We are an independent, non-governmental and non-profit organization dealing with the management and improvement of the water environment. We have members from nearly all European countries. We have different type of membership. We have national members, so would be normally water association operating at a national level, mainly on wastewater, water body management. Some of them will see to drinking water, and they will do also technical standards, training, and so on. We have corporate members such as IDEXX, also sponsored members, and research members, which will be university department dealing with water. And due to our various scope of members, we aim to be a forum for discussion on key technical and policies issued in Europe. And in order to do so, we arrange events, conference, workshop, meetings. We have working groups and expert group. And as you know or potentially know, EWA, we have always strongly supported water reuse, and we are very, very pleased to have two speakers to discuss this further with us today. So a few households. First, please only use a chat box for interaction, but use a Q&A box to submit your questions. Would be great if you could also mention to which of our two speakers your question is addressed. This webinar is recorded, so you cannot switch on your camera or mic, so there is no point for you to raise your hand. So really, please use the Q&A function, the Q&A box. Yeah, so that will be it from my side. And we then have two speakers. The first one will be Dr. Roberta Marchettone from the Joint Research Center from the European Commission. Roberta, you're an expert in water reuse and wastewater treatment with a strong focus on risk management. So you hold a PhD in environmental engineering, and you have extensive experience in developing and implementing EU guidelines and regulation for safe water reuse. You are a scientific policy officer at the European Commission Joint Research Center, and you play again a key role in advancing the EU water reuse agenda, collaborating with stakeholders to promote innovative solutions and best practices for water reuse. I used to always say that you are the person in charge from the Commission for Water Reuse, and I'm sure everyone knows you already, so I don't think I have to introduce you further. And I will introduce the second speaker, and then the floor will be used. Then our second speaker, Dr. Brett Perrin, who has been active in the field of microbiology for over 3 decades. You have over 25 experience, practical experience in product development and the analysis of water for the presence of delicate organisms. and you work closely with laboratories, experts, and regulatory bodies around the world, developing new technologies, training analysts, and establishing best practices to optimize open complex technical procedure and generate focused methodologies. And you are here today in your capacity of global lead of scientific affairs at IDEXX Water. So that will be our two speakers. We'll take to the two presentation one after the others, and then we'll have a Q&A session. So I will stop sharing my screen. Roberta, the floor is yours.
Good morning, everybody, and thank you, Arthur, for the introduction, and thanks a lot for inviting to present this EWA webinar. I will start sharing my presentation, so let's see, maybe I can do entire screen, might be better. Let's do like this. Can you see it? Can you see it?
Can you see presentation mode? Perfect. We see it screen.
Okay, thank you. So just please give me a notice because I have no clock around me. I do have, and I cannot see myself. So in case there is some, just give me a hand. And yeah, thanks again for inviting to this webinar. And thanks for the introduction. So I will skip since you introduce myself quite accurately. I will skip my introduction and I will jump directly to focus on what is the topic of my presentation. I will today I will try to make a kind of different focus of the presentation of the EU water use regulation, focusing more on the microbial requirements, so we can open discussion following the presentation of Dr. Berwin. First, I will introduce the Joint Research Center of the European Commission. For those that are not aware, we are the European Commission's department that provides science and knowledge service throughout the European policy cycle. So we carry out research to provide independent scientific advice in all the phases of the European policy cycles, from the drafting to the implementation and evaluation of policy and regulatory framework. We are located in 5 places in all over the European Union, and I work for the Ocean and Water Units that supports policies on freshwater and marine governance. Specifically, I work for the Water Lab, supports policy on water reuse, and we are located in Ispra in the north of Italy. So water use now is not a novelty with the regulation. We just entered 6 years from entering into force of this regulatory framework that applies to agriculture irrigation. The water use regulation was relaunched within the water resilience strategy that was published now 1 year ago. And is part of other regulatory framework looking into having a broader approach to protect the public health. The regulation sets harmonized requirement for agriculture reuse. And the water use is also mentioned in the recast of the recent Urban Wastewater Treatment Directive that reinforce wastewater monitoring, public health, and the One Health links. And the wastewater now is it's also seen in the European policy context as both as a resource to recover and as a source also of public health information through wastewater surveillance and monitoring, all very important information that then they will help in promote and help implementing water use in agriculture irrigation, but also in other sectors. So which which roles the JRC had in providing scientific advice in the draft regulation. Since the very early years, around since 2014, after a first impact assessment of the need of and the potential of water reuse in the European Union, particularly in agricultural irrigation, the JRC wrote a report and conducted a study to identify the minimum quality requirements for water use in agricultural irrigation and aquifer recharge. These minimum requirements were drafted considering international guidance from the World Health Organization and International Organization of Standardization standards and principles, and they were then integrated in what they are known as minimum water quality requirements for under the European Regulation 2027/41. We also, after the entering into force of the European of this regulation, we contributed to the technical support for its implementation, especially on the risk management plan. So we drafted guidance on how to develop a risk management plan for water use systems in agricultural irrigation. And in the current phase, we are entering the phase of the evaluation of the water use regulation, which will the European Commission needs to perform by June 2028. It's in a couple of years then, but we are from June 2026, the member states that they had the obligation to report the data on their water use systems that have been, they got permits in their country. So we will start analyzing also what is happening in the national level regarding water use, and analyze this data and support the European Commission in performing the evaluation that will cover all the aspects of the regulation, from the minimum requirements to the risk management, also to expand whether to expand the regulatory framework to other uses. So let's focus on the microbiological requirements of the regulation and what is the approach and the framework that the regulation is it's requiring when implementing water use systems. So the Annex 1 of the regulation demands the respect of minimum requirements for agricultural irrigation. It's minimum microbiological mainly requirements harmonized in all the European Union, divided in quality classes, draft mainly from the ISO approach. So the classes are from D to A, with increasing E. coli concentrations from the lowest exposure to the public health to the highest exposure to the public health with class A. E. coli is the main parameter that is required in the minimum requirements, in addition to other specific parameters that they need to be identified in the specific water use systems and under defining exposure circumstances. For example, Legionella, when there is a risk of aerosolization, or intestinal nematodes when the irrigations, when the reclaimed water is used for irrigation of pastures and forage. But the requirements of the regulation, they don't stop at the E. coli. The E. coli is chosen as a practical standardized compliance indicator, but it must be complemented to all the other requirements of the European regulation that include the risk management plan, but also for Class A, the validation monitoring, and also the use of the multi-barrier approach to ensure that the water is safe through all the water use system. So the Annex 2 of the regulation requires the risk management plan that it's a mandatory and very important instrument in the regulation because it goes beyond checking water quality requirements at the outlet of the reclamation facility, but looks at the broader water use system to help to identify hazard, exposure pathways, a receptor, considered in the local conditions, the crop types and the exposure of crop types in the contact with the reclaimed water, but also the people exposed, potentially exposed in the water use system, considering the workers at the reclamation facility and the farmers, the bystanders and the whole environment. The risk management plan is a lively process, is required before the water use system produce the reclaimed water in collaboration with all the actors involved in the water use system to collaboratively identify hazard, assess risk, and then identify control actions. When particular risk for microbiological risk is identified, it can be the risk management plan will further integrate a specific risk assessment for pathogens that may be relevant for the local context. Not only pathogens, but also other contaminants of emerging concern and for example, antibiotic resistance determinants. The microbiological requirements of the water reuse system when we are looking into class A and then highest exposure to the public health, so reclaimed water that's used to irrigate crops that will be in direct contact with the reclaimed water, then the regulation requires a check that the treatment train of the reclamation facility can reliably achieve required microbiological performance. And this is required in the Annex 1, is known as validation monitoring, and it applies only for Class A and only for the new plants in operation or plants that they are under significant changes in their treatment systems, and use log reduction performance target to demonstrate treatment robustness on three classes of pathogens, so bacteria, protozoa, and viruses. You can see a general table in a general leader table of what are the log reduction requirements, mainly for the three indicators for the three classes. And the validation monitoring is required to focus on process capability, not only on the outlet quality of the given sampling day. So it's something that needs to be performed before the system is in operation. We are aware and we are collecting examples and case studies and then challenges on implementing validation monitorings for border use for Class A in different examples. We are currently having a collaboration with ESAMUR in Murcia, where we are ESAMUR is performing validation monitoring for Class A for 3 different reclamation facilities with different technologies, and sharing with us challenges that will help to see if further guidance is needed and if the validation monitoring requirements are working. So we have typical observed challenges on how to select the indicators, on the analytical sensitivity and the method, the frequency and the design of the sampling phase, but also what happens when there are when you cannot achieve the required log removal, when the inlet of the wastewater is below the log reduction already, and the outlet has very few colonies, for example, in case of bacteria, at the outlet of the reclamation facility. Another important aspect to protect the public health under microbiological requirements is the use of the multi-barrier approach. This is something that sometimes it's difficult to understand, that is embedded in the regulation. But the multi-barrier approach, it's something that is mentioned in the Annex 1, mainly on defining the water quality class that they will need to that needs to be produced, and then reach the agricultural feed. from the production of the reclaimed water until the use of the reclaimed water in the agricultural field. There are numbers of barriers that can be used, that goes from treatment performance, controls on the storage and distribution system, the irrigation method itself, or also practice that they are in place that they can further reduce the risk of being exposed to a pathogen when the reclaimed water is used. So the minimum requirement is seen as a starting point and a compliance point, but all the water needs to be safe until the point of use, using the information that have been analyzed under the risk management plan, and also the possibility to implement additional barriers that will also reduce the risk in case there is something happening at very beginning of the reclamation facility. Also to support the application of the multi-barrier approach in collaboration with the University of Bologna and SEDEX, and also with the Environmental Agency of Portugal, the Portuguese Environmental Agency, we are drafting a guidance where we can further give examples and explain how to use the multi-barrier concept, especially when a reclamation facility is delivering a water quality class lower than A, and then has in-field crops that they would require a higher water quality class. But not only this, but also how the barriers and the various example and the irrigation methods can be seen in under this log removal approach that is it's proposed in the regulation. And then I'm almost done, right?
Yeah, 3 minutes, please.
Okay, yeah, almost not closing. So we are also looking at what are the additional requirements that member states have been added in their national legislation. There are Spain and Portugal that they already have the regulation in place, and they added some specific requirements based on a national risk assessment, mainly on previous practice that were already in place, that they were not that they prefer to keep. For example, Spain added Tania in their minimum requirements, and Italy is planning to add Salmonella. While Portugal is more looking at using the risk-based approach to link with exposure, so suggesting which pathogens to look under specific exposure. Collecting also the member states data and what is happening in their national legislation, so expanding the minimum requirements or the framework, minimum requirements plus risk management plan to other uses. We are already looking at to see how, if we can extend the risk-based framework beyond agriculture, so for urban uses, environmental uses, and industrial reuse. Again, we are looking at what the member states are doing, and there are already some examples on how the approach of the regulation is being implemented in other sectors, considering the type of end use, from urban uses, street cleaning, industrial use, cooling system, or golf parks. And what are their minimum requirements that the member states are proposing. We can see already in Spain, in Italy, in Portugal, also in local regional legislation, there is this expanding of the approach to other uses through fit for purpose quality based on the risk assessment. And at the same time, in parallel, we are conducting a survey to collect data on this information that I have presented during the presentation. So not only challenges, but also what is happening in the member states implementation. So I invite everybody to to participate to our survey. It's open to everybody. We try to divide it from governance to academia and utility operators, and also to explore the centralized system and other uses, and it takes only 15 minutes to answer. And these are also the JRC activities that we are conducting. We had 2 webinars this year, presenting case studies on risk management plan and post-point of compliance barriers. We developed a serious game on water use risk management as a training tool to understand the risk management plan practices. As I mentioned before, we are drafting guidance on validation monitoring, on multi-barrier guidance, and also methodology environmental risk assessment. And it just accepted a paper on AMR in water reuse. And I also advertise the International School on Water Use that will be in Turin this September from 14 to 17, and you can find further information at the link. And also to continue to stay engaged, you can subscribe to our mailing list, and also look at our website where you can find all the past webinars. I will also put this one at the end. And we are starting mapping water use project the EU. So in September, we will launch another survey to collect case studies. And thank you for your attention.
Thank you very much for the presentation. We will also share this survey link into our email to the participants after it. So let me just share my screen directly, and we will move to the presentation before taking the time for the Q&A. So I hope you can see my screen.
Welcome everybody. Thank you for joining us. It's always a pleasure to talk to people. Thank you, Roberta, for that great presentation. This will be complementary to that for sure. And I'll just try and give things on a more holistic perspective from my point of view. Next slide, please, Art. So we all know this: water is essential. It's a primary good, belongs to everyone and is for everyone. It's essential, irreplaceable, indispensable to life. Looking at the Urban Wastewater Treatment Directive, one of the primary objectives is to protect the environment from adverse effects of wastewater discharges from urban sources and specific industries. That means protecting the environment. That means protecting the public. Next slide, please. We all know this is happening. Adverse environmental events are becoming more and more common. In specific, I'm talking about flooding. They're becoming more common. The effects are very, very surprising, however. Next slide, please. Unfortunately, what is happening... Oops, sorry. Unfortunately, even though we're having more of these flooding events, adverse weather events, rivers are drying up, reservoirs are running low. We're having incidences where crops are failing, and this is becoming more and more uncommon. It's kind of counterintuitive that you would get more flooding, but we're running out of water at the same time. Next slide, please. I spoke to one of my colleagues in the industry, and he said one of the issues that we're having, particularly where I'm based in the east of the UK, is we're having the wrong type of rain. If we get light, steady rain, this soaks into the ground. This helps to recharge aquifers. Also, when it's percolating into the ground to an extent, it self-decontaminates, removing the microbial load. The problem is, more and more commonly, we're having these deluges of rain. So we get significant urban runoff and flooding. We have overloaded treatment systems, and we have an increased microbial load. Ultimately, we get reduced surface and groundwater levels. Next slide, please. The solution to all of this, and this is why we're talking about water reuse, reusing urban wastewater for suitable applications. That could be industrial usage, it could be processing, such as cleaning streets, and it could be agriculture. They have lower treatment requirements than we would have, say, for drinking water. However, at the same time, we also have to increase our water resilience. We need improvements to our infrastructure. We need improved policy. We have to anticipate, prepare, and respond to these challenges. We have to respond to floods, drought, and water scarcity. We also have to improve our water security, so the quantity and quality of the water that we have, that's important for health, life, and ecosystems. So we need reliability, sustainability, and water that's adequate for an intended application based on acceptable risks. Next slide, please. As Roberta mentioned, there are a number of relevant guidelines, minimum requirements for water reuse. We have technical guidance on water reuse management, particularly in terms of agriculture. Next slide, please. If we look at urban wastewater, this can be mixtures. It can be domestic wastewater. It can be mixtures of domestic wastewater and non-domestic, so coming from industry. It could be mixtures of domestic wastewater and urban runoff, or a mixture of all three of those types of water. So what can be done? Well, first of all, we have to look at improving water treatment and looking at routine parameters to monitor the water quality itself. We have to be looking to improve public health through water quality and applications. We have to look at increasing the applications for wastewater and for byproducts, but doing it in a safe way based on risk management. We also have to look at improving the infrastructure and the environment which we serve. Next slide, please. There are a number of challenges, however, associated with this. Number one, pollution. A lot of micropollutants present in water, particularly microplastics, phosphorus, nitrogen, biological oxygen demand, that can lead to what we call eutrophication, particularly nitrates and phosphates. Those coming from agricultural runoff are extremely important. They result in algal blooms that can increase biological oxygen demand, and that can affect the ecology of a particular water source. There are also a lot of energy implications for this. Energy use is increasing. We need that for processing the water treatment, processing water effluents, and energy use with regards to infrastructure. We also have to look at transparency and how things are implemented. Transparency from one member state to another or from one region to another varies. It's very uneven, even in this digital age. It's very, very uneven. There's also even application of the Urban Wastewater Treatment Directive and the policy that we call polluter pays. So somebody that's violating a particular regulation should be responsible for resolving that. Next slide, please. So looking at the objectives of the revised Urban Wastewater Treatment Directive, protecting EU citizens and ecosystems. It's not just about people, but it's also about the environment. Looking at the remaining sources of insufficiently treated wastewater. It aims to provide a predictable framework for the sector, increase its transparency, and align with a Europe fit for the digital age. It aims to align the sector to the objectives of the Green Deal. This is looking at the 2050 objective at climate neutrality. And it aims to use wastewater health-related parameters as a support for public health, improve adequate and equitable sanitation and hygiene for all, whilst maintaining a sufficient quantity and quality of water. Next slide, please. And carry on one more. So with regards to microbiological parameters, as Roberta already mentioned, we took a holistic approach. So if we look at the EU Drinking Water Directive, we have parameters, primarily Enterococci and Escherichia coli. And the values there are 0. And that's based on a count per 100 millilitres typically, except for bottled water, where the volume is increased to 250 millilitres. Thinking about domestic systems, it's also important that we consider Legionella bacteria. The value there is less than 1,000 per litre, particularly where outbreaks have occurred and we need species identification. Next slide, please. We also look to the urban EU Bathing Water Directive. Again, primary parameters, Enterococci, Escherichia coli. Looking at inland waters, so fresh waters, excellent quality water would be fewer than 200 Enterococci per 100 mils, E. coli fewer than 1,000 per 100 millilitres. And we also have values set for good and sufficient quality. Similarly for marine waters, primary parameters are Enterococci, Escherichia coli. Excellent quality marine waters would be 100 Enterococci, less than 250 E. coli. Why do we use Escherichia coli and Enterococci? Primary reason is E. coli doesn't proliferate in the environment for very long. So it's an extremely good indicator of recent fecal contamination, which indicates a risk of other pathogens being present. Enterococci survive better in the environment. So they're longer lived, and they provide an indication of more historical fecal contamination. That's particularly important with regards to bathing waters, but also wastewater. Next slide, please. As Roberta said, with regards to use in agriculture, you have the 4 classes of water, various treatments that are applied to those, and various levels for parameters such as E. coli, biological oxygen demand, total suspended solids, and turbidities. Also considering Legionella species. However, I'm a large proponent that there's a huge case to focus primarily on Legionella pneumophila rather than Legionella species, as it's the primary cause of Legionnaire's disease and is the most significant cause of that particular indicator. Also helminths, again, in some cases, depending on the application for that water type. Next slide, please. Similarly, with Class A water use in agriculture, E. coli, colophages, Clostridium perfringens, and again, we're looking for specific log reduction in the numbers of those particular pathogens before we apply that water for use in agriculture. Next slide, please. What other parameters could we consider? AMR is becoming increasingly important, particularly with regards to wastewater. We have people that are looking at SARS-CoV-2. Other emerging pathogens, we have to consider these as we look to revise the guidelines. One possible is non-tuberculous mycobacteria. There are other chemical parameters that are coming out, particularly PFAS, what we call forever chemicals, that are surviving in the environment for long periods of time. Again, we have to be monitoring these to ensure water is safe for its intended application. Possibly other viruses, polio, influenza. And again, there are always others. That's why we get groups of like-minded people together all of the time to consider the parameters that we should be looking at. Next slide, please. Everything is based upon risk assessment, and Roberta alluded to this a little bit. Application of the Urban Wastewater Treatment Directive 2024, looking at the identification and assessment of risk. The parameters that we've outlined are minimum requirements, but what we really want member states to be doing is going above and beyond and looking for additional risks. Identifying risks with drinking waters, bathing waters, ground and surface waters, marine waters, aquaculture, putting stringent values on the quality of these water types, but also looking for potential risks and parameters. Next slide, please. One reason why risk assessment is critical if we're looking at water reuse for agricultural use. If we're using drip irrigation, Legionella is probably a low risk parameter. If we're using sprinkler irrigation, where we're aerosolizing that water, Legionella is going to be a high risk parameter. So we have to look at the application for that water type and assess the risk and monitor the water routinely. Next slide, please. There are a lot of benefits to this directive. We're looking at potentially a 44% reduction in toxic load, particularly in risk areas, a significant reduction in E. coli emissions. And what that would mean would be discharge of wastewater into urban tributaries. Looking at cleaner water to preserve biodiversity, preventing eutrophication. So we're maintaining the ecology of a particular water source. And there are also some new business opportunities and innovative measures that can be applied. And the next slide, please. So in summary, water is essential, but it's increasingly scarce commodity. Water reuse is becoming an absolute requirement, but that water quality must be suitable for a particular application. We have to routinely monitor that water for chemical, but also microbiological parameters to ensure quality. And analyses other than the bare minimum in the directive should be considered. As part of that, risk assessment for a particular application is absolutely essential. And I believe that's my last slide, Arthur.
Thank you very much, Brett, for your presentation. So I think, as my colleague mentioned it in the chat as well, please use the Q&A portal in order to ask your questions, and we will take the first one. It's the only one we have from Bastian Schiffer from Bayern. Roberta, I would say it's for you because it's probably a new presentation. So because you mentioned some requirements, and people use there also chemicals parameters.
Yes, I believe that Brett covered this at one point. He showed what are the minimum requirements of the water use regulation. So the four classes from D to C, there are, I mean, for all the classes, there are the additional parameters in minimum requirements for BOD, TSS, and turbidity. Until class B, it complies with the Urban Wastewater Treatment Directive requirements. We have to remember that the regulation applies to effluents from urban wastewater treatment plants that then they are further treated for reclaimed water. And for class A, they are defined below 25 milligram per liter for TSS and BOD, and then turbidity below 5. And as also Brett explained in much more details, there are additional parameters that might be included, and all this based on the risk assessment. So the risk management plan, it's actually a tool that requires to identify all those additional parameters that are case specific for the water use systems, and these would include pharmaceuticals, for example, to answer to the question directly.
Thank you very much. Do you want to add something to that?
No, I think Roberta covered it perfectly.
Okay, thank you very much. Roberta, I think we're having echo on your side.
You have echo?
Yeah.
I will mute.
Thank you. I think I saw one comment, Brett, I think from one of your slides in a chat, mentioning strange to read the excellent threshold from the EU Bathing Water Directive for E. coli is higher than a good quality one. I think was a reference to.
Yeah, it does seem counterintuitive that excellent, good, and satisfactory water qualities would be somewhat different. It's based on percentiles, so it's based on a 90th percentile or a 95th percentile of the water samples analysed. That's how those numbers are determined. But those are the numbers that are provided in the Bathing Water Directive, so that's what we work to at the moment.
Thank you very much. Once again, do not hesitate to ask your questions. Otherwise, I have some for you, a bit prepared, and you touch upon about it, Roberta, first. So you mentioned that, okay, the EU water reuse regulation, so you have harmonized minimum requirement for agricultural irrigation, but of course, implementation depends a lot also on local risk management and local condition. So from your perspective, so like where would you see like a biggest practical challenge for member state and operator to implement the regulation? Like will it be governance, monitoring, translating risk management plans into day-to-day decision or something else? Because I'm assuming it will be also what you will be looking at in upcoming months. Thanks.
So are you you are focusing on agriculture irrigation, so in the current status of the regulation?
Yes.
So throughout the member states and over the last 3 years, there are been challenges that at the beginning it looks like it was more related to technical challenges on the risk management plan. But after this best practices exchange, clarification, guidance, and utilities, operators, and authorities started drafting risk management plan, there was a shift on overcoming more the technical challenges to governance. So what we are observing is that there is implementation of the regulation. There is member states that they are updating national legislation to comply with the regulation, also expanding the requirements and the framework to other uses. For example, Spain, Italy, Portugal. Cyprus is more focused on agriculture irrigation. It really depends on the requirements of the demand in the sectors of the regulation. And what it's observed, it's mainly at governance level. For example, in Italy, there is overlapping legislation that make it difficult to understand the permitting process. In Italy, it's still a standby on publishing the national legislation, although at regional level, so regions that they have authority, they are already implementing the regulation for agriculture irrigation when local conditions, also local governance conditions are permitting. In other member states that they are not focusing yet on agriculture irrigation, there is some delay on in fully implementing the regulation. There is still going on in Germany, for example. But other member states, they are drafting for the first time their national legislation to look at expanding to other uses, urban uses. It's one of that, irrigation of parks, but also industrial application. We can see that is moving. So there are several challenges, but it also depends of the country.
All right.
Could I also make a comment on challenges? Sure. Okay, thank you. Having spoken to a lot of my colleagues in the industry around Europe, one of the biggest challenges that keeps being a recurring message is the cost involved. And ultimately, the cost of water, you might not want to hear it, but the cost of water will have to increase. Why is that? Obviously, we do have a requirement for safe drinking water, and there are utilities which are the custodians of that safe drinking water. But we're asking them to do more and more analysis. We're asking them to improve infrastructure so that they can continue to provide that safe water, whether it's drinking water or to reuse. And so ultimately the costs are going to have to increase. Although they have the responsibility to provide that safe water, it's a two-way street, and we also have the responsibility to be able to help them fund that. So ultimately, cost of water is going to increase. It's a big challenge for everybody, but it's a natural progression, I think.
All right. Thank you very much for that comment. I think Brett will say with you, we had another question coming in the Q&A portal. Because you mentioned AMR and a participant mentioning that they have challenged to analyze AMRs in wastewater. Do you have any suggested methodologies for measuring it according to different type of bacteria type? And
yeah.
We also, yeah, please.
So the JRC is moving forward with a dual approach to AMR testing. So there's a culture-based approach to testing for AMR using either solid-based media or liquid culture. and there's a PCR approach to looking for the genes that supply antimicrobial resistance. Why is there a dual approach? Well, culture-based methods are usually more implementable in the majority of laboratories, particularly small laboratories around the EU. They're already set up and geared up to do those culture-based methods. PCR, particularly qPCR or digital PCR, is much more specialized. There's a lot more equipment involved, the setup costs, the training requirements for the analysts. So a dual approach seems much more practical. Just to give a very, very quick example of how you can do that, you can take an existing method, for example, ISO 9308-2, and then you can do two tests, one where you run the sample as is, and one where you run a replica, including a fixed amount of an antimicrobial. And then you compare the numbers that you get and determine, for example, the number of ESBL E. coli that would be present in that sample. I can go into it in more detail offline. Please contact me if you want more information.
Thank you very much. Now, what I just wanted to add is that actually 4 weeks ago, we already did together with IDEXX another webinar that was actually on AMR and urban wastewater treatment directive. And today's webinar is recorded. So from there, you will find the recording on our YouTube channel from the one from 4 weeks ago. I would say, Roberta, next one will be for you, as it starts with, does the European Commission foresee any future plan to move from encouraging water reuse to making wastewater reuse mandatory in certain sectors or regions, particularly in areas facing increasing water scarcity?
Encouraging for sure. We are looking as a European Commission of what we need to do, like to encourage water use. One is also address public perception that they are one of the barriers of the challenges in implementing water use. And also which further guidance is needed for encouraging water use, but it's not looking at having mandatory water use in any regions of Europe. There are some indications at member states level that they have voluntarily but not mandatory target for water use. But it's at member states level that we conducted an analysis, and it's generally there's not this approach to make it mandatory. What we observe is that when there is a need, then the demand will increase for water use. And our example regions of the European Union, for example, Cyprus and the region in Murcia in Spain, they reach 90% of using wastewater because there is a clear need. And now we need to see also when the drought is increasing and other sectors are looking into having reclaimed water, for example, in the industrial sectors, which change between the southern European countries and the northern West European countries. The demand is different. Then I believe that the demand will be created by itself.
Thank you very much. Brett, do you want to add something on this?
No, I think Roberta covered it perfectly.
Okay, thank you very much. We wait, I would say, half a minute to see if we have one last question. Otherwise, I'll give you the floor for closing remark. Okay, so it does not seem to be the case. So let me start closing remark, let's say a minute per person. I share my last slide. But you mentioned a bit already on your discussion how to develop, let's say, water reuse to scale it in Europe. Of course, an important aspect is also public trust. So questions for closing statement for you. If you want water reuse to scale in Europe, what is the one microbiological requirements or monitoring principle that you believe is the most important for building public trust? So Roberta or Brett?
Go ahead.
Roberta, go ahead.
No, go ahead, because I'm still thinking and I saw that you were ready.
I think we have to look at monitoring public health to help instill public trust in water reuse. It always sounds to the public when we're looking at, for example, using biosolids in agriculture, using water reuse for agricultural irrigation. It always sounds a little bit, I'll use the word nasty to people at first glance. So we have to be monitoring public health to ensure that people are safe, the foods that they eat are safe for them for a particular application. But also just reinforcing that message, reinforcing that particular message that what we're doing is appropriate. It's been looked at by experts, and we are taking all the necessary precautions chemically and microbiology to ensure that water is suitable for its application. Over to Roberta.
Yeah, I fully agree with what Brett just said. Public health is very important. It's important also to the education on the water cycle, because there is also this approach to believe that the water is not circular, but in nature the water is circular. And we can and this is something that is not obvious to the public perception, and also education needs to show that we have the technology to have the required quality for water use. In the European Union, we are starting with water use from agricultural irrigation and other uses, but in other parts of the world, water is reclaimed also for indirect or direct potable reuse. And there is also here a big push in having the citizen and the public involved in the really understanding what is happening when we are reclaiming water. So public perception is very important, and communication of the water use systems, it's very important. So awareness campaign and communications with everybody that is involved. It's important, but it's also important sometimes the public perception also falls in the authorities, in those that they are actually working in the water use system. There are some challenges and that they are related to public perception also at operators and authorities and others that are mainly involved in the water use system, and that specifically also in the method of the risk management plan. And for that, it's training and understanding, because there is a switch now from one quality for all table to risk assessment, and this is something that is slowly uptaking in the sector. And I believe that after this initial resistance, you start seeing that the sector is understanding and is applying the concept.
All right, thank you very much for your reply. I can only agree with everything that you both said. Now, so first of all, again, thank you very much for you and for the participants for the questions, and for you speakers for taking the time. As we mentioned, this webinar is being recorded. It will be updated on the EWA YouTube channel in the upcoming days. So here you can see our two next upcoming events. So we'll have an introduction course to EU legislation and policy. You will see on a nice black and white the same water reuse tables, and shared with Roberta with pictures with the class A, B, C, and D. And we'll have our Brussels conference talking about water security in Europe under pressure. You can have more information about upcoming events. There will be webinars after the summer break as well on our LinkedIn channels, our website. You can also register to our newsletter, and you will have a quick survey feedback after the call. So please take the 2 minutes to help us, let's say, make it even better next time. So thank you very much again. We hope to see you soon. And thank you very much to you, Roberta, and you, Brett, for taking the time and for the clear discussions today. Thank you very much, and I wish you all a good day.
Thank you, everyone.
Thank you so much. Bye.
Bye.